Good afternoon, everyone. My name is Harry Campbell. I am the Science Policy and Advocacy Director here in the Pennsylvania office of the Chesapeake Bay Foundation. Today, we are honored to have with us a gentleman that I have known for quite some time in the form of David Wise. David is a great guy, super knowledgeable, as you'll find out, and one of the funniest individuals you'll ever meet if you have the opportunity to do so. It's just really fun to hang out with them and to experience that sense of humor. But more importantly, well, not more importantly, but what he's going to talk to us today is about an update on forest riparian buffer research. You know, most of Dave's work is oriented towards working with farmers on the technical and financial assistance needed to implement agricultural best management practices, particularly forest riparian buffers throughout Pennsylvania, but currently really focused in Southeast PA with his work at the Stroud Water Research Center. There, he conducts research projects on forested buffers, works with landowners, and manages a whole myriad of program elements associated with best management practices and stream improvement projects. Prior to joining the Stroud Water Research Center in 2013, which boggles my mind, Dave actually worked where I am, the Chesapeake Bay Foundation. In fact, he was right across the hall from me. For 15 years, he was over there. Now he's over with Stroud doing somewhat similar work and really deep diving into a lot of the science. Dave has degrees in natural science management from the University of Wisconsin and Penn State's College of Agriculture. He lives near Lancaster-Lebanon County line in the woods, where he enjoys his family time and all kinds of good stuff associated with that. So without further ado, I'd like to introduce to everyone David Wise. And before I officially pass it off to Dave, I just want to say, for time's sake, we'll be taking questions at the end.
Thanks, Harry. And if you've not experienced the downside of Harry's sense of humor, that's something to look forward to be victimized by that. There are many stories. So are you looking at my presentation, Harry?
Good.
Great.
Got it.
Nice. So I work at Stroud Water Research Center, and one of the privileges there is we have some science knotheads who can analyze data and such matters. And I get to overlay some science questions on our watershed restoration projects to answer a few questions. So special thanks, CDF and the K10 initiative actually is financially supporting some of this research for reasons that are obvious because they want to know what's working. And clearly there's a whole lot of technical expertise here at our own facility that's part of this. There's gonna be two main categories of ideas presented, things that are research topics, you know, full-on science that could be, hopefully will be at some point in peer-reviewed journals. And then there are some case studies that don't qualify as rigorous science, but have insights to share nonetheless. I think it's important to discriminate between the two. Some of this stuff I'll mention just quickly in passing, and if you want to follow up with me, we can later on. My email address will be at the end. This center hole net method I recommend to you. If you're still doing the tassel method on the right, you're probably experiencing some tangling that you wouldn't need to. You can see the right-hand photo. If the nets get neglected, that's what happens. The center hole method, where, slipping back 1 second, about an inch and a half diameter hole in the center, gives those emerging tree leaders a fighting chance to get out, as you see there. It's about a 75% reduction on tangling, even if you just neglect the nets, which happens too, unfortunately. This next topic is actually one of the real cornerstones of what we're excited about right now. Trying to figure out some alternatives to herbicide for protecting trees from voles. Here's the 3-foot glyphosate spot that's been the industry standard for a long time. That's for very good reason. Here's data that Sweeney published in 2002 that showed about a 5-fold increase in survivorship by using herbicide spots around sheltered trees. And oh, by the way, the growth rate more than doubled on those trees. So we don't want to leave these trees languishing in a size class that's vulnerable to voles. We want to get them moved along. So the herbicide spots have been the gold standard. 2013, we recognized, hey, there's reasons to get away from herbicides if we can. So we started looking into the three things that you see here: a vole guard, some coarse 2-inch diameter clean stone, and then some 2A modified stone. Only the 2A modified showed any real potential. So we went into our second generation of trials, putting that head to head with the 36-inch herbicide spot. We did a 20-inch diameter by 2-inch thick stone mulch treatment, and we did a 12-inch diameter. That's about 40 pounds of stone to do 20 inches of diameter and about 20 pounds to do a 12-inch diameter. Big difference on amount of material. The 2A modified is simply this: it's crushed stone with anything bigger than about a 1-inch dimension screened out. So all the fines, very importantly, all the fines are in there, and it's a mixed gradation of sizes. It's not clean stone, there's not voids left between the stones. So in that trial, here's survivorship. The survivorship bars you'll see are all gray. The growth slides are all green bars to help you discriminate. And what this is saying is that herbicide spot actually is somewhat less effective at survivorship than a 20-inch stone spot, and about the same effectiveness at keeping trees alive as a 12-inch diameter stone treatment. So in other words, to say the stone is working as well or better than the gold standard, which was the herbicide spot. Here's the growth data. Not statistically significant between the herbicide and the large diameter. And we give away a little bit of growth on the 12-inch diameter. It's not a big, cushy, free to grow, suppressing all the competition for light, nutrients, and moisture. So we're giving away a little bit of growth rate. My trees, if anything, grow too fast, and I'm happy to give some of that away for reasons that you'll see here. So in the last 2 years, we installed more than 100 acres using this 2A modified. We're feeling very positive about this. And we have some sites that we have a lot of reed canary grass. We were a little cautious, and we actually pre-treated those spots with herbicide before putting the stone down. But some of the test areas where we didn't do that, we're not having any trouble getting good survivorship without any use of herbicide, even in reed canary, which is fairly amazing. We weren't counting on that. If you were to look at cost, the herbicide spots are expensive. That's 8 mobilizations. It's about $8 per tree over those 4 years. We're not always sure it's going to get done. And then once you're done, the survival and growth in years 5 through 8 is in question because those trees are still not beyond the size class where voles can do their mischief. The stone mulch, turned out that particular contractor, his guys were thrown on 2 shovels full, turned into not a 12-inch that I asked for, but a 15-inch. That cost just under $3. We do that one time. There is no follow-up. We're not going back and spraying, so we don't have all those remobilizations to get out there again. And that stone should be doing good work in years 5 through 8 is our hope. We'll be monitoring that. Okay, so this one is not coming through. This is a video of a guy putting 2 shovels full of stone around a tree shelter. Very exciting stuff. So it's not high tech. I think that the critical thing here was we found it was really useful to have a skid steer or other piece of machinery to get the stone to the site. So that guy's going to take 2 steps, put 2 shovels full. Oh, here it is. Okay. Really exciting stuff. And you're going to see him pat this down. You don't need to pat it down. You just need to level it off a bit. And then the next time there's a rainstorm, it'll settle it in and it'll move along and it'll be just fine like that. So some considerations for project management. You can see the list here between the herbicide and the stone. Clearly, we're trying to get away from the chemical. A lot less mobilizations with the stone. And think about that in a grant window where you might have a 2 or 3 year grant, trying to get 4 years of herbicide spots. Now you're stretching projects into multiple grant cycles. Can be sort of a nuisance just on fiscal management. One of the things that has shown up is we don't get a lot of snow here in southeastern Pennsylvania where I do my work, but voles do not respect herbicide spots once there's snow on the ground. They will go into that area and they will do damage to trees underneath the cover of snow. And we believe that the stone is working underneath the snow, an additional advantage. Two real drawbacks to the stone mulch: flood impacts. We had 2 100-year events on the same site in the first 2 years after installation. We lost about 5% of the stone, meaning from about 5% of the trees, which was good news. That was a very wide floodplain. Were that a tighter constrained valley site, we may have lost more. So the stone can wash away or be buried in sediment if floods are happening. Hopefully you don't get lots of floods by happenstance in the first 3 years of the project's life, but it can happen. And then we had one really wet site where we had trouble getting a delivery truck to, and we had one site with very steep valley sides that we had trouble getting a delivery truck to for the stone. So that can be a challenge. If you do a reed canary and you're really nervous, you can do the combination, do a one-time application of herbicide before you put the stone down. We found it was not critical to do that, even in reed canary, which I was a little bit surprised by. So we're happy about the stone mulch. Changing gears, look at the slide on the right. That is Oriental bittersweet coming out of a tree shelter. More biomass of Oriental bittersweet than the tree that is in that tube. This is what happens when birds are defecating seeds down the tube, or if there's just seed bank in the soil. So that's really disheartening. It's a challenge to figure out how to solve that problem. So we were doing some hand weeding, lifting the shelters and weeding stuff out. We've switched to using pre-emergence herbicides. They're granules, a product called Snapshot. We, in late February, early March, put a shaker, one shake like your salt and your French fries, put a shake down each tube, and it prevents seed germination of those invasives down inside the tube. We did several generations of trials, different products, different frequencies of application. And what we found out was we were having breakthrough of Oriental bittersweet, but it was because the stuff simply timed out. So we found out we need to do 2 applications a year, one in February or early March, and then again in May. And then we were weed-free through August, and that has been working really well for us. Next set of tests. I have been on the quest for the holy grail of which is the right tree shelter. I did a whole bunch of stuff back in 2007, only to find out that it didn't really matter. Pick a good shelter and use one, but it didn't really make a lot of difference. So here I am. Why am I back at this again? I'm back at this question again because of this problem. Here in southeastern Pennsylvania, we have trees that outgrow their own internal strength. The tops get too heavy for the stems, and they flop over, they kink the tubes, they snap the ties, they break the stakes. And when the mowers come and want to mow the site, and there's 15-foot tall trees, 12-foot tall trees laying on the ground horizontal, they're unamused and they don't know what to do about that. And it's hard to fix these things once they start flopping. So I was looking for a tube that would slow these things down or build enough internal stem strength that they don't do this. That is categorically what I was looking for. I didn't get an answer to my question, but I'll share this data because it does say some other things, meaningly, primarily that you can pick your tube based on things other than survivorship and growth rates, because there's not a lot of difference. A little bit of an advantage to the Plantra tube over the TubeX versions after 4 years, not a lot. A little bit of advantage for growth. That was the first slide was survivorship. A little bit of an advantage on growth, not a lot. And I'm not sure for my context that's even welcomed, frankly. What I was interested in was, are we growing a thicker stem that is less likely to flop over? So we were actually taking caliper measurements of the trees 6 inches above the ground and looking at their diameter of stem based on the shelter that they were in. And what we found out was, the plantras are growing faster, taller trees, but they're a little bit skinnier, statistically significantly skinnier, which was a big surprise. The plantra folks told us they would be growing a thicker stem. The trees would be happy to sit in the tube longer because it's a brighter tube than the green Tubex products. So I didn't get my answer. What it is to say, and then we went in, the third bar on the right there, you see a product called Shore Green. That's a new product on the market last few years, essentially a lower price version of a combi in many regards. So we were curious whether it would work as well. It's lower priced. Survivorship, exactly the same basically. And growth, largely the same, no statistically significant difference. And interestingly here, the planter tube grew things less well than the combi. So those patterns are not, real pronounced. These tubes are doing basically about the same thing. So what did I conclude? Here in Southeast PA, I don't think there are important differences in terms of survivorship, growth, or stem diameter based on the tube type of those leading tubes. The Shore Green, now we've added through 2 years of data and we don't see any differences there either. So that gives you the freedom to choose your tube based on price, based on ease of installation. Tubex makes a rock solid tube that you can pretty much beat into the ground. The plantra system, it's a lot less rigid and is more of a challenge to get a good soil seating, to get that tube seated well into the ground. Although I will say, as tough as it was to get those in the ground, there was no increase in mortality. It's not like the voles were sneaking in and doing damage. I will say this plot was also protected with stone mulch, which has been highly effective against the voles. So another thing we're looking into, second from the bottom thing, flopping syndrome. There may be some evidence that the plantra fiberglass stake, because it can flex with wind and snow load or whatever else, it can move the tree around, primarily wind, that maybe it's going to grow a stronger stem, if not a larger diameter stem. So we're going to actually investigate that, putting fiberglass stakes up against some wooden stakes. There's some voices that are credible saying, hey, when you don't let the tree move, it doesn't experience the stresses that lay down the lignins and the other stiffeners that will prevent that flopping, that we are creating that floppy tree by the fact that we've used a non-flexible wooden stake and the tree is simply not moving enough to experience the stresses that it needs to develop the strength. So we'll do some future trials on the tube type and that stake flopping rate is something we'll look at. We haven't seen data in the past on mowing frequency, so I thought, okay, let's get some data sets on mowing. What can we spit out there that may be helping to shed some light on this question? Mowing is a big cost. It is important for managing competition from plants. It's important for reducing habitat for voles. Although I will say with the stone mulch, we're just not seeing vole damage, and it leads to the question, can we reduce our mowing in that context? So here's some of the test plots that we were running. We did 4 different mowing regimens. The first being the no-mow, not simply not mowing. A quick taper where we start off mowing twice in the first year, once in the second year, and then move into no-mow. A slow taper, and then the last treatment on the far right, 3 mowings per year, every year for 4 years. And that's expensive. We're talking thousands of dollars of difference in cost between a no-mow and a full mow 3 times a year for 4 years. I pay $160 an acre for a custom mower to come in. Do that 3 times, that's $480. Do that for 4 years, we're pushing $2,000 just for mowing. What did we see in survivorship? Not a lot of difference. Again, these trees were protected with stone, so mowing or not a lot of difference. I would say these 2 first bars, the likelihood of repeating this experiment and finding out that no mowing has statistically significant better survivorship than frequent mowing, I think that's an unusual aberration that I wouldn't expect to have happen again. Growth data, not surprising. Tapered mowing starting out with 3 times a year and the 3 times per year mowing every year for 4 years, they had statistically significant more growth than the less frequent mowing, the no-mow category and the quick taper where we're tapering off the no-mow. This is only through 2 years of data collection at this point. So I don't think that's surprising. I do think it is significant and good to have a data set. You know, with the stone mulch, we're in a position now in the past, let me back up just a second. When we were relying upon herbicide spots for vole protection, we were sort of obligated to do at least twice a year mowing because we needed to get the spray crews in to have them work efficiently. We can't have them fighting through blackberry and nettles and waist-high stuff, never mind the difficulty of doing spray applications, but just physically getting through the sites with backpack sprayers. Now that we're not doing those backpack sprayer herbicide spots, we can back off on our mowing. There's no particularly compelling reason that we need to be in there mowing. And my suspicion is we may go to a once a year mowing just to keep some of the nasties out, you know, multiflora rose and blackberry and stuff, because we do want to go through and do maintenance of other types, shelters and bird nets, and you know, sometimes there's flood damage and whatever else. So you don't want to lose access to the site, but maybe we can get away from 3 times a year to once a year. It'd be a huge savings. Moving on to the last of the science topics. We have heard now over the years some voices suggesting that you can't grow forested buffers on legacy sediments. I think there may be some motivational drivers to those claims. Purveyors of those kinds of projects don't like to lose site opportunities. To, you know, once a bunch of trees are on the site, it complicates the idea of going in and convincing somebody to dig out all the sediments. So there were claims being made that you can't grow buffers on legacy sediments, and I was chafing with that. Finally, Burns said, well, let's put some science to this. He and some colleagues here at Stroud did the science, had it published in Restoration Ecology, and the answer is you can grow trees just fine on legacy sediments. In fact, the deep, rich, better drained soils of legacy sediments on these floodplains are not challenges to reforestation. They are actually helps for reforestation. And if you do remove the legacy sediments, you can still do a buffer restoration project, but effectively what you're doing is you're taking away a lot of well-drained, rich soil, and you're putting the trees in much closer to water table and the challenges that soggy soils bring to plants of all nature. So you're going to limit your palette of trees and shrubs that you can use successfully on that increasingly soggy site. There's good reasons to remove legacy sediments. I'm not saying there isn't. I object to the idea that you can't grow buffers on legacy sediments. I just don't think that's not borne out by science or by a lot of personal experience. And then moving into case studies, a little bit on tree shelter removal, a little bit on shrubs, multiflora rose, and reed canary. So this, I've got 2 quick slides here for you that I think have something profound to say. I was part of the professionals in 2007 whose best professional judgment at the time was we should be taking shelters off when trees at the top of the tube are reaching 1.5 to 2 inches of diameter at the top. And that was because there were shelter types on the market that did not have a burst feature and would girdle the trees starting at the root flare at the root collar where the trees, flare out the bottom and first fill the tube. These tubes were constricting the trees and leading to physical damage. And there was some concern with gathering of organic matter and high moisture conditions inside the tubes as well. So that advice, removal at 1.5 to 2 inches at the top of the tube, that stood for a long time, and I had no data to speak to it. I was increasingly getting the opinion that that was premature to remove them then. So finally now what we've done, we've looked at more than 1,000 tubes doing these 3 treatments that you see here: full removal, when it got to be that 1.5 or 2, splitting the tube top to bottom with a case knife, a little bit of a hook. They make utility knives with a little bit of a hook on so you're not slicing into the bark as you go down through. And then simply leaving the tube in place, the far right. So here's what we found out. You're looking at, so across the bottom here, this is trees. We had 100 trees that we fully removed the shelters from. And by year 3, almost 50% had been buck rubbed. And that's really disheartening. These were 18 and 20 foot tall trees that are now dying back to the root crown. They are stump sprouting. Very few of them are going to die outright. But we've lost, 15, 20 feet of growth. They're out of the tubes. Are the deer just going to browse those stump sprouts into oblivion? Are they going to rub them again? So they're taking those tubes off. We really saw these things hammered pretty hard, losing their top growth. Where we split them, split the tube top to bottom. Here's the 3-year result. After 3 years, a cumulative of about 9% had buck rub. This is a large sample. We didn't, you can see we were really nervous about exposing too many of them to rub by taking the shelters off. So 90% we didn't remove the tubes from. We split them and we left them. Very little buck damage where the tubes were left in place. And then, where the tubes were split. And then no damage whatever on where we left them fully intact. And I will say we learned one thing. When you split that tube top to bottom, let me see if I can go back. When you split that tube fully top to bottom, it's fairly easy for wind or buck rub or different forces to just fully remove that tube, and then you're basically left with this. So what we're doing now is we're splitting from the top to the middle. We're leaving about 2 inches of intact tube here in the center, and then we're splitting from there down. And we only do that if we run into some specific evidence that the tree is suffering from that tube being on there. Otherwise, we're just leaving it in place and letting the tree burst out of it on its own. And we're just not seeing rub on those trees. So, so far, we are out of those 426 trees, we don't see a single individual tree that's showing adverse effects of the tube being left on. Keep in mind, this is only 3 years since they would have been at this 1.5 to 2 inch size class. So some of the slower growers are just now filling the tubes. Some of the fast growers have already burst the tubes, and the tubes are now coming off, like from sycamores and river birch. But there's still a chance that we may run into problems with neglecting tubes in place. And I think we're just going to have to follow them and watch. If you've been using multi-stem shrubs like silky dogwoods and arrowwood viburnums, we've been unclear how to protect them. 2-foot tubes with a lot of deer pressure. Yes, the tube works so you can do your herbicide work, so the voles don't kill them, but the trees, the deer just get them. So these are the lollipops of silky dogwood. Right next to this is this plot, where we simply put a 4-foot high welded wire fence around those same 2-foot tubed shrubs, 2 years of growth, these silky dogwoods are more than head high. So it's working. Do you want welded wire in the floodway? It's not ideal. So what else can you do? Well, we're looking at what else you can do. So we're trying some individual cages, also expensive, labor intensive. We see this working, also has its liabilities in the floodway. We are also looking at putting multi-stem shrubs like that silky dogwood into a 5-foot tall tube. Here's a shot of them in a cluster. So a little hard to tell the top growth from the stuff in the background, but here are silky dogwoods in 5-foot tubes coming out the top in their 2nd year of growth. Anecdotally, we are seeing this working. We're not confident enough to recommend it widely at this point. We want to watch this a while longer, see what happens. And here's a concept where I said, what happens rather than leaving this one shrub on its own? What if we put these in on 30-inch centers, a cluster of them, like a dozen or 9 or a dozen? Do they offer any protection among themselves? Deer are lazy animals. When these things start to sucker out from under the tube, and this gets to be a little bit of a thicket, it may be that the only browse that ever happens anymore is around the edges, and all the interior growth is free to grow. So we'll see. We're seeing some hopeful signs that 5-foot tubes can work on multi-stem shrubs. And 5-foot tubes will do just fine in floods, of most types, unlike the cages or wire. Multiflora is a challenge. Here's my contractor, Bill Tatey, hands on hip, saying, what do you got me into this time, David? We had about 4.5 acres of head-high multiflora rows. He said, I think this is our answer. We spent almost $2,000 an acre to mow those roses down, and now all the roots are live in the ground, the tops are just gone. So we did our normal planting. We waited for those roots to push new rose growth. When they were 2 and 3 feet high, we went in with a bulk tank, a hose, and a spray wand, and we sprayed every square foot of that site with rodeo, glyphosate-based herbicide. That killed the rose, killed the roots. The trees were in tubes and they were fine. We then only had, a million or a billion seeds that wanted to push up the rose to reclaim the site. So we seeded it really heavily with pasture grass. We limed and fertilized. You can see really high density of pasture grass seeding in the inset. And here's what it looked like after 2 growing seasons. And here's the before and after, just in case you think I'm playing tricks on you. So it worked. It was not cheap, but you can get ahead of rows if you're serious about it. The other one that I hear some people talking about is unbeatable is reed canary. And I'd say pick your species carefully to the increased hydrology and do your maintenance. Here's a site through 2 growing seasons with 8 and 10 foot high trees. They're doing just fine. This is reed canary grass. We're using our normal methods. You just have to do your maintenance, is our experience. That here where we're using herbicide spots, we are finding some evidence that we can get away with just using the stone mulch. But if you're nervous, the herbicide is on your side. If you can't get a mower in, then just do like a 4 and 5 foot diameter spot. Moving forward, we'll do some more tests. Can the fiberglass stakes reduce flopping? We want to try some stone inside the tubes rather than using Snapshot. We're going to follow tubes in years 5 through 8 to see if the stone mulch works better than herbicide spots in those years. We have some biodegradable products in the market we want to demonstrate, and we're going to keep watching those trees where we have not removed the shelters to see whether we're running into any problems. So there's my contact info. Harry, I'll let you manage us through Q&A, and I'll say thanks for your kind attention, and hopefully I can shed some light on some issues of relevance for you.
Thank you, Dave. That was a wonderful presentation. I really appreciate you taking the time to walk through an update as it pertains to all the work that you guys have been doing over there at Stroud. At this time, if anyone would like to ask any questions, I'd be happy to just come off mute, ask your question, or if you'd prefer to use the chat feature, do that, and I can read it off for everyone.
Explain it well enough, or not well enough to even generate questions?
Sign of a thorough presentation.
Are there questions that you guys are asking yourselves? You know, I have the ability to overlay some questions onto the research, to the plots that we're putting in, turn them into research plots. You know, if you have things on your mind, I will consider suggestions.
We do have a question that came in from Joan Orak. She says that I used 2A stone, but the grass is growing up into it. Do I need to spray?
Yeah, I would say just keep in mind that we are doing that 2A modified stone for vole protection, not for eliminating vegetative competition. So you saw in that one slide that where we only did a 12-inch spot, there was some loss of growth rate. And we expect that because this stone is not going to completely suppress. It probably will reduce the density of vegetative competition. But the small diameters compared to the 3-foot herbicide spot are nothing nearly as cushy and free to grow as that herbicide spot. I'm happy to give away growth rate. I don't see my site suffering from that. In fact, they may benefit because of the issues I have with floppers. But if you're up in northern Pennsylvania and growth rates are really slow and it's a concern, it's something to be aware of. I have not heard many people doing the stone mulch. I think hearing experiences across the watershed will be real valuable. So I'm curious, are you concerned that you're going to give away growth rate that you're worried about if that vegetative competition is not reduced?
Bill asks, not sure if you mentioned this, but how many trees per acre are you recommending?
Yeah, that's the shale versus limestone is a great question. And I hope I'm on the right question here, Harry. There's a real difference between the calcareous nature of limestone and the non-calcareous nature of shale. And we thought we would see some unhappy pin oaks, for example, with the limestone because of the high alkalinity that it puts on the trees. We haven't seen that. I can't explain it. I would have expected the acid lovers like pin oaks to not like that limestone, but we've not seen it. So I think you could use either if you're worried about that. Shale 2A modified is there. 2A modified is only a commentary on particle size assortment, not alkalinity attributes.
That's a good point. Bill asked real quickly, how many trees per acre do you typically recommend?
Oh, so we are typically, and Lamont Garber, and my good colleague, and I have running discussions on this. He likes to put in 200 like Krupp does. I'm putting in 125. And partly that's just for me to have a little bit cushier budget for the maintenance side. And then Lamont says, well, Dave, if you're saving so much money with your darn stone mulch, why don't you plant more trees with that money? So somewhere in the ballpark of 125 to 200 is where we're comfortable. So
we have about 5 minutes left. Another question from Bruce. Do certain trees or shrub species have different survival rates when in buffers?
I have not followed that with science. It's a fair question. I know from experience, you know, there's some rock solid performers. Silky dogwoods tend to be stronger than red osiers. The gray dogwoods, don't stand over top of them once you planted it because they'll poke you. You know, they really grow fast and they can be clonal forming and actually aggressive and invasive in some regards. arrowwood is such a high performer. There's a lot of other ones, you know. Service berries don't seem really robust. Maple leaf viburnum does not seem really robust. I haven't seen cranberry viburnum being so robust. So I think let your experience guide you. I don't have science to offer you on that.
Certainly seems like the site and the area of the state that it is in could have some variability as to that as well.
Sure. Hydrology matters.
Yep.
Light levels matter a lot. And one of the odd correlations I found is the tree form shrubs that do well in 5-foot tubes tend to also be tolerant of understory conditions, whereas the multistem shrubs tend to be more sun needing, higher light levels, and tend to also be more tolerant of wetland conditions. So there's sort of an odd correlation between understory, maybe not so happy in the soggy, but tolerates the shade with the tree form, versus the multistems that are different ecological niche.
Fascinating. We're coming up on our end time. So if anyone has any other burning questions for Dave, now you certainly could. I'm sure you're willing to continue the conversation offline through email or otherwise.
Yep.
But if there aren't anything that's on people's minds, we could certainly call it today.
Thank you, Harry, and thanks to audience members. Let me know if you have got questions. Follow up.
Awesome. Thank you, everyone. Have a wonderful day.